Well, welcome back. Online students, can you hear me?
Yep.
Yes.
Yeah.
Yeah.
Okay, good, thank you. Okay, today we will cover chapter 3. By the way, last week, Marywood University reported students infected. So we're aware about that. So let's see. Today in class, 7 students here. And I don't know on Wednesday how many will come. So wait, if there is any announcement from a university about the online or just keep going quarantine, hybrid, whatever. But let's see. If there is not many students to come to class on Wednesday, I may make only one day in class, like Monday in class, and then Wednesday totally online like that. So I will look at it, how many students will come, and then if we need, I will post like a survey if you want or not want, and or whatever opinion. Okay, chapter 3, forecasting. In operations management, last time we covered what is operations management. Then do something to make better, cheaper, faster. So forecasting, what does it? Is there any relationship with the operations management? Forecasting. Why we need the forecasting to make better, cheaper, faster? What do you think? Why we need the forecasting? Okay. Yeah. Do we have? Yeah, good. Yeah. So if we want to produce something or sell something, then we need inventory like that. Then if we can forecast future demand, then we can plan how many we should produce, or we should buy and then make stock to sell in the future like that. So forecasting is important in operations management. Later, we will talk about like inventory management and so on. By forecasting, if we know future demand, but if we don't know future demand, then we don't know how many material, how many people we need, how many labor need, how many inventory we need like that. So in that case, if actual demand is like 100, but we don't know, so just buy like 200, what problem? Too many, right? That case, we need an unnecessary inventory cost or something like that. But the other side, actual demand is 100, but we buy like 50. What's the problem? There is no demand. There is opportunity we can sell, but we cannot sell because out of stock, like that. So forecasting is important in operations management. Okay, In operations management forecasting, what we should forecast? Demand. If we know future demand, then we can prepare, we can plan. So demand is one of our forecasting thing in operations management. Demand management purpose coordinating and controlling all sources of demand so that productive system can be used efficiently and the product delivery on time. Efficiently, if we know exact amount of demand and then prepare and plan optimal size, then cost low. Remember efficiency? If we can make it cheaper, then efficiency improved. So right amount we know and then prepare plan right amount, then lower cost. We can eliminate unnecessary cost and then delivery on time. So by right forecasting, we can prepare and plan and then deliver on right time. Okay, demand, there are two types of demand, dependent demand and independent demand. Okay. I will use the chalkboard behind. Can you see online student behind me? The chalkboard?
Yep, you can see it.
Seeing okay? Seeing okay? Okay. Thank you. Okay. If what looks like car, right? Without tire. Tires. Okay. Usually 4 tires, except that the spare tire, regularly 4 tires. So demand of car, like a finished product, and then demand of tires, part or component, raw material. Okay, which one is independent demand? Finished product or part? Yeah. Product is independent? Are you sure? Yeah. Sure, yeah. Even student answer right answer, then when I reply like, are you sure? Then, well, right. So finished product demand is independent demand. Then part demand is dependent demand. Why? If we know final product demand like 1,000, then automatically we know 1,000. So part component raw materials demand depending on independent demand final product. So dependent demand, independent demand, dependent demand, the demand for a product or service caused by the demand for other product or service, depending on other product, final product. And the independent demand is not derived directly from that of other products. Okay, next. Components of demand. If demand up and down, and so on, like this, actual demand, then there are components, average demand for the product. Here, this line, average demand, that from add all demands during the period and divide by the number of term. And seasonal element, second one is seasonal element. Here, up and down, same pattern again and again. Seasonal elements and cyclical elements similar, but term, how long? How long repeat again and again? The length of term, length of repeat again like that. Seasonal elements such as ice cream demand. Usually, generally, ice cream demand during the summer high. Spring, fall, middle, and winter, during the winter, low. And next year, the same pattern again. Next year, same pattern again. If the same pattern repeat every year, that is seasonal elements. If we can find that the pattern, that is seasonal element, cyclical element. So it's the same pattern again and again, repeat every 2 or more years. Every 2 years, every 3 years, the same pattern repeat again and again, that is cyclical elements. Random variation, no pattern, just move itself. So if there is random variable or variation is in certain demand, then we cannot use that data or demand for forecasting. And trend, here, up and down, but long-termly looks like increase. That is trend. Sometimes increasing trend, sometimes stable. There is no increasing or there is no decreasing, stable or long-termly decreasing trend. That is trend. And then types of trend, linear trend, curved linear trend, and asymmetric trend, exponential trend. The first one, linear trend. If we find the trend, then it looks like straight line, that is linear trend. If we find trend, but it's not straight line, instead curve, that is we can call that non-linear or curve linear. This case looks like, where's cursor? Looks like S curve. So we call this S curve. I'm not sure if we know about that, but I think you know. Typical product life cycle looks like this. There are 4 phases. Online students, make it better looking. Let me change. How can I change? Yeah, good. Online student looking better, right? Bigger.
Yeah, that's good.
Changes. In-class student also look the same screen. Anyway, there are 4 phases in product life cycle. Introduction, growth, mature, and decline. So go back to slide. Come on. Go back to slide. This one, S-curve trend, looks like here. The same, right? And then next one, asymptotic trend. Asymptotic trend. And next one is exponential trend. Okay, question. Which trend? Yeah. Here, growth. Growth. Is my pronunciation okay? Growing. Yeah. Growth and mature and decline. Okay. Between 2, asymptotic trend and exponential trend, which one is typically for the new product? (50-50) shot. Which one? Asymptotic or exponential? Which one is for the typically new product? Any online? Okay.
Is it exponential?
Yes, right. Exponential. Look at this. Here, introduction phase in product life cycle. At the stage of introduction, first time, people doesn't know what it is, but later they know, and then the increasing rate is increase. Here, looks like introduction part of product life cycle. So exponential trend is typical new product trend. And then asymptotic about this part. So already matured or already in market. Okay. The next one. Oops. Types of forecasting, there are two types, qualitative and quantitative. Qualitative, without numeric data, using others' opinion or estimation forecast. That is qualitative. Quantitative, using numeric data, then forecast. There are two types. Time series analysis and causal relationship. Time series analysis and causal relationship similar. Using X variable, forecast Y variable. Looks like this. So Y axis, X axis. So using X variable, forecast Y variable, then usually function equals Y equals A plus BX. So X variable is independent variable. Y is dependent variable. I think you are familiar with this equation or function. You took statistics, right? So hopefully your instructor covered this one. So if X variable, independent variable, is related to time change, then X variable change, and then based on that X variable, forecast. That is time series analysis. Causal relationship, the same, using X variable, independent variable, forecast Y variable, dependent variable. But not time related. They have correlationship between X and Y variable, such as temperature and ice cream demand. Temperature increase, ice cream demand increase. Temperature decrease, ice cream demand decrease. So in that case, temperature will be independent variable and ice cream demand is dependent variable. So using time-related X variable, independent variable, then that is time series analysis. If we use correlationship such as time, temperature and such demand, that is causal relationship. Both are using numeric data such as past data, and then some data using correlationship, then forecast. So they are quantitative forecasting. Okay, some types of example of qualitative techniques in forecasting. Judgmental method. Based on a process of collecting educated opinion from individuals or a group. Before I came here to Marriott, I worked at Troy University in Alabama, Montgomery, Alabama. In Montgomery, Alabama, in Montgomery, Hyundai plant, and then near border of between Alabama and Georgia, Kia. So I met Hyundai and Kia people. Then I did research about their performance and so on. So I asked Hyundai, what do you think about next year's and whatever Hyundai cars demand? And the person said maybe 10% increase next year. 10%, 10, something number, but not based on numeric data, just opinion. So if I'm a dealer, then I prepare something 10% increase for the next year. So like that, without numeric data, like past data, just use their opinion, then forecast. That is judgmental method forecasting. So jury of executive opinion or sales force composite or opinion. So based on the composite or opinion forecast. And next one, secondary source information using published information, like a Wall Street Journal, Standard Poor Index, whatever. So using their information, such as consumer market survey, then forecast. Next one, Delphi method. Delphi method is similar to judgmental method. Judgmental method using individual or group's opinion, similar, but a group of experts, using group of experts, like economists, practitioner, professors, using experts, a group of experts, opinion and forecast. And then this one is kind of combination of qualitative and quantitative. So steps like this: choose experts, whoever they are expert in that area, and then questionnaire, using questionnaire or survey, get opinion, and based on that opinion, and then if they can collect data, numeric data, then using that data, forecast. That is the Delphi method. Okay, next one, time series analysis. Using time-related X variable, then forecast. First one is simple average, simple moving average. Nowadays, coronavirus data. I don't know if you look at the data or not. State data, national coronavirus data, they use 7-day moving average. You know why? Many experts said the daily case increase. Certain point and daily infection case decrease like that. You know, there is kind of a trend. Cyclical or seasonal trend. During the weekday, the case increase. During the weekend, decrease. And again. So the repeat term is like weekly. Maybe because of the number of tests. So during the day, the number of tests increase, weekend decrease. So to offset that variation, use 7-day moving average. That is a simple moving average. Just simply add whatever terms and divide by the number of terms. If we use 3-term simple moving average to forecast term 4, use previous 3 terms data, add and divide by 3. So it's like from this one, F4, forecasting 4 equals A3 plus A2 plus A1 divided by 3. Actual term 3, actual term 2, actual term 1. So from the data, 800, term 3 is 1,000 plus 1,400 plus 800 divided by 3 equals, that is 1067. So this is 3 weeks moving average. So next term, F5 equals A4 plus A3 plus A2 divided by 3, that is 1,300 and so on. If we use 9 terms, F10 equals A9 plus 8, 7, 6, 5, 4, 3, 2, 1, and divide by 9. Oops. We cannot see. Next term, and next term, and so on. So this is a simple moving average. Now, For the coronavirus data, they use 7-day moving average. And next one, by the way, actual, black one is actual. And then blue dot is 3 weeks. And red line is 9 weeks. So more term make more smooth, more flatter forecast. So using this simple moving average itself for the forecasting, sometimes the actual demand data is fluctuate. So if we use raw data, that case maybe forecasting is not accurate. So that case, using whatever terms, moving average, and then using that moving average data for the forecasting. So now, say again, the coronavirus daily case data, 7-day moving average, and then using this 7-day moving average data for the forecast like that. Okay, next one is weighted moving average. Simple moving average, the same weight. If we use 3 terms like F4 equals A3 plus A2 plus A1 divided by 3, then this one comes from A3 times 0.333 plus A2 times 0.333 plus A1 times 0.333. Their weight to make the final output the same. That is simple moving average. But sometimes the idea like this, most recent data more important. That case, give higher, like a 0.5, 0.3, 0.2, like this. Give a different weight depending on importance. So that is weighted moving average. For example, if actual data month 1 is 100, 2, 90, 3, 105, and so on, then forecast F5, then give weight. Recent data more important, so give weight 0.4, 0.3, 0.2, 0.1 like that. Then times 0.4 times 95 month 4 most recent, 0.3, 105, 0.2, 90 plus 0.1, 100. By the way, always the sum of all weights equal to 1 should be, you know, your grade at the end of the semester, your grade based on this weighted average or weighted moving average. This semester I will get rid of attendance score, but it's like assignment 40%, midterm 30%, and final 30% like that. So your score, assignment score times 0.4, your midterm times 3.3, and so on like that. That is kind of example of weighted moving average, weighted average. And next one, by the way, so 30%, 30%, 40%. That is 0.3, 0.3, 0.4. Add up, the result is 100%. So the sum of all weights should be equal to 1. That means 100%. And then exam kind of practice F6. F6 A5 times 0.4, the same weight, apply the same weight. So 0.4 times month 5, 110, plus 0.3, second recent month 4, 95, plus 0.2, and next one, 0.2 times 105, plus 0.1 times 90, that is 1025. What time is it? 4:41. Okay. Here. On Moodle, usually if we cover quantitative parts, calculation, then I post practice problem. If this is a regular time class, then I give you a practice problem and then let practice problems. But this time, keep the social distancing and then minimize contact. So I don't give you a paper practice problem, instead on Moodle. So I will open this one. It takes time. Just a moment. And it's green. Here it is. Yeah. What the? Okay. So question number 1, A and B. Very simple. So try 2 questions wherever not in class. So I will post an answer later. Okay. So practice yourself, and then I will post an answer later. And then later find the answer and then I'll compare with yours. Okay, that's all. And see you Wednesday. Any question? Okay, online student, any question?
Are we submitting one in A and B?
Excuse me?
Are we submitting one A and B? Or just doing it for ourselves and comparing?
Just compare with my answer.
Okay.
Okay. Later, if you ask me to go over, then I will go over. Okay. Okay, that's all, and see you Wednesday. And then hopefully no problem.
Thank you, Bud.
Thank you.
Thank you, Professor Kim.
Thank
you.
you.
Have a good one.
Thank you. Distance. If you want to come to Wednesday, there will be enough seat, so it's up to you. Okay.